This equation, we must first assign notation. Let's say that 1 plus 3 plus 5 plus 7 and so on to the 2n minus 1 term is equal to S of n, which means the series of n. And we can also observe that the sigma summation of k equals 1 of n of k is simply equal to 1 plus 2 plus 3 plus 4 and so on to the nth is equal to n times n plus 1 over 2. So now let's use that. Let's write it down first, and so on to the nth term is equal to n times n plus 1 over 2. So now let's set up n is equal to 2 times n. Since the third term, since the 2n minus 1 term, since 1 plus 3 plus 5 plus 7 converges to the 2n minus 1 term, so that means that we can set up the factorization using 2n. So now, first let's observe that this, we can just split it up into 1 plus 3 plus 5 plus 7 plus and so on to the 2n minus 1. And then we add the remaining 2 plus 4 plus 6 and so on to the 2n. 2n is equal to 2n times 2n plus 1 divided by 2. And we can cancel it out, which means that this is Sn plus 2 times 1 plus 2 plus 3 and so on to the nth term, which is equal to n times 2n plus 1. Sorry, wait, I meant this n. Okay, so using the same equation, we get that Sn plus 2 times n plus 1 over 2 is equal to n times 2n plus 1. We cancel out the 2 and then we move to the other side, so that means that Sn is equal to n 2n plus 1 minus n times n plus 1. Therefore, we can factorize and we get that Sn is equal to n times 2n plus 1 minus n minus 1. And we cancel it out. So that means that we get Sn is equal to n times n, or Sn is equal to n squared. And we need to remember that Sn is equal to 1 plus 3 plus 5 and so on to the 2n minus 1 term. So that means that we get that 1 plus 3 plus 5 plus 7 and so on to the 2n minus 1 term is equal to n squared. Hence, we have proven the identity.